standards, allowing them to determine the size of the different fragments generated by the enzyme digests, both the single and double digests. Students should add up the fragment sizes for each digest, and they should all be equal. This is the total plasmid size.
So as you can see, EcoR1 has a 70 and a 30 kilobase size fragment, which equals 100. For HAE3, there's a 40 and a 60 kilobase size, which is another 100. And then for the double digest, there's a 40, 30, 20, and 10, which altogether equals 100.
If the fragments don't add up, it is likely that there are fragments of the same size superimposed on the gel. That is, two fragments of 50 kilobases each will migrate the same distance on the gel and appear as a single band, even though there are actually two fragments of 50 kilobases present in that digest. So let's make a plasmid map. Start with a circle and pick one enzyme and put its initial site at 12 o'clock. Place the second cut at its correct position based on size. It's arbitrary whether this is the large or small fragment.
So as you can see, we've put the EcoR1 cut sites on the circle, and we arbitrarily just started with the 70 kilobase size fragment clockwise from the first E that is placed at 12 o'clock, and the second fragment is 30 kilobases.
Ask yourself if the smaller fragment is found in the double digest. If the answer is yes, then let's try to retain that fragment uncut. This means that the second enzyme will make both cuts in the larger fragment.
So as you can see, the 30 kilobase fragment is found in the double digest, so we're going to try to retain that.
By trial and error, place the second enzyme sites in the large fragment so that you get the appropriate sized fragments for the double digest.
So let's try making the first HAE cut site 40 kilobases from the 12 o'clock position. That leaves 30 kilobases in the larger 70 kilobase EcoR1 fragment. That then must be cut again into a 20 and a 10 kilobase fragment, so that we've got all of the fragments in our double digest, a 40, a 30, a 20, and a 10.
But while this means that we'll either have a 20 or a 10 kilobase size HAE3 single digest fragment, which doesn't work because we know those fragments must be 60 and 40 kilobases. So try again.
So what if we make our first HAE